Great. Welcome, everybody. My name is Paweł Tomasik, and today I'm going to talk about expression trees, with the focus on EFCore use cases. This is pretty unique feature because from the one hand is really powerful, from the other rather obscure. Actually, you can go pretty far as .NET developer without using it. I would even risk a statement that you can go pretty far as .NET EFCore developer without using that explicitly. However, explicitly here is a keyword because now EFCore from its very foundation relies on expression trees really extensively. So why this kind of talk? Actually, there is a group of people which personally I belong to that simply likes to know how the stuff that they are using every day works under the hood. And there are a few other reasons that will be revealed during the next 40 minutes. So let's don't waste more time and move to the code. So of course, we'll start with defining what the expression is. However, I'll try to start from the bottom and defining what the expression is not. And the expression in .NET is actually not a delegate. It's also not a delegate wrapper or Lambda wrapper. Although if we compare the declaration signatures and add to them this compile method, which converts the expression into the function, we may jump to this kind of conclusion. However, that's really far from reality. Actually, apart from the fact that those two .NET beings may look similar at the code level, at least, they don't have much in common. So how they differ? So we already seen the declarations and the type definitions, so they are a little bit different. But in the code level, we can declare both Lambda or delegate. I will use Lambda, the keyword in the rest of that presentation, and the expression using actually the same syntax. However, at the runtime, the situation looks completely different because Lambda is just a piece of compiled code which can be executed, while expression is stored in the form of tree, which can be compiled in the runtime and later on executed. And so let's zoom in to this tree structure and see how this trivial example is represented in memory. What kind of classes are used to express this simple statement? So this tree will actually contain three nodes. The top node would represent the operation, something that we have in the middle, and that would be of type binary expression with subtypes less than. And we'll have two subnodes. First, it will be the parameter expression representing our age parameter, and the last one will be a constant expression representing this value. All of those classes actually are derived classes from the base expression class. Great. However, the question arises, so who defines those classes? So we already seen that we can define the expression nobody in our code using Lambda-like syntax. So where are those classes? So to analyze that, I'm going to use sharplab.io, which is a free online tool that helps us to dig into some .NET internals. What we can see here on the left-hand side is just our input, while on the right-hand side, we will see the code, which more or less would be a product of our input compilation and later on decompilation. So let's see what's going to happen if I declare in our main method Lambda, and with this simple trivial body. So what will compiler going to do with this kind of line? We'll just create for us some implicit internal method with a body equivalent to the code we written here. More or less, it looks like that. And later on, this reference to that method is used whenever we use our Lambda in our code. However, if you add, this expression keyword here, so create expression with the same logic, now this output looks completely different. So instead of our internal class, we got a bunch of factory methods. So we have this parameter expression, binary expression created from less than methods, and so on. So the conclusion is that this Lambda-like representation of expression is nothing more than a syntax sugar, and it is a compiler task to translate it, translate it into the regular set of raw factory methods from expression API. Right, so if we know how it is more or less created, we can try to analyze that code. But maybe instead of that, we'll try to write our own. That would be probably better idea. So I'll just close it and move to our first example. And in this example, I would like to create the expression using this raw API that will represent this logic. So here I define it as using this lambda syntax, and right now I try to do it manually. So I will start with this bottom nodes of our expression, so the parameter and the constant, as we've seen in one of the previous slides. So first would be our param, and that can be created using expression.parameter factory method, and I need to define the type of that, which will be the int in our case, and there is an optional name for that. It is not mandatory, but it's convenient to add it for better readability. And the second subnode was our 18, so that's kind of constant expression, so let's name this way. And of course, there is appropriate factory method, which is called expression.constant. And right now, we can define a body, so the top node, which would be binary expression, and particularly that will be less than. And it, of course, takes two arguments. So first is our parameter, and the second is our constant expression. And we are almost done. We can verify if something what we created is equivalent to the stuff we wanted. So let's run that code and see the output. Okay. So as we can see, we are almost good, because this is regular expression created with lambda-like syntax. The two-string representation of that looks like that, so like lambda. But something what we created looks like that. So it seems like only the right-hand side of our lambda. So actually, it means that there's one additional step that we need to do if we have raw body of our expression. We need to convert it to the lambda expression, and of course, there is corresponding method that is intended to do so. So, and it is called, of course, expression.lambda. But here we need to provide the types of our lambda explicitly, and it will be the function of int to bool. And parameters for that factory method is just body and our param. And that's all. We can check if we are good. We also verify if we compile that and try to execute it against, for example, 32 and maybe 3 to see if that works as expected. So I just run that and verify if that works as intended. So we got correct output. Right now, our manually created expressions look exactly as this one generated by our compiler, and the output seems that it works as intended. You may wonder why actually you need to bother with this kind of approach, which is looks like as a boilerplate. So actually, the answer for that would be revealed in the next example. So just be patient at the moment and switch back to our presentation. So we ended here. So just resume that. And we can ask the next fundamental question: what are actually usage for expression? So what is the benefits of having expression like that represented in this kind of tree? We already know that we can compile it in the runtime and later on execute. We can call the string method that can more or less, in some cases at least, the code we just written. But these use cases are pretty poor. Finally, we can do something more practical. We can, for example, analyze this tree and try to convert it, translate it to some other language, like Python or Java or whatever. But maybe the most suitable example at this point would be attempted translation into the SQL statement. And this is what actually EFCore internals do. EFCore is trying to analyze this tree structure and generate a SQL query from that. We, of course, the best effort attempt. So the approach here is something is useful, then it shall be supported. And EFCore does pretty good job with that. So whenever we use some contain, starts with or other string methods, EFCore will translate it into the corresponding SQL string functions. Most of them have some equivalent functions. The same is valid for all kinds of arithmetic, bitwise operators or methods, and they usually have appropriate SQL functions as well. If we use in our code ternary operator, there is this case when SQL syntax that is equivalent in some cases, and we use null coalescing operator. There is of course coalesce statement in SQL. And finally, if we use the contains method over some enumerable that is no custom one, like some list of valid towns that would result in where in statements. So there are a few examples of that. Of course, the full list of supported methods is now available in the EFCore documentation. Two things I would like to highlight at this point is that this list of supported methods is kind of wide list. It means that whenever is not on that list, it means that it's not supported, including all kind of custom methods, even if they are most trivial, even if they are invoking built-in string methods, EFCore would not be able to translate it. And the second, maybe even more important thing is that although we are using C# syntax to define our logic, it's not the C# code that ever going to be executed. Instead, the SQL statement would be executed, which is a product of this translation procedure. And usually it does not make huge difference, but sometimes it is actually really important. So let's take a look at the next example I would like to show. So let's switch to number 2. And in this code snippet, I can assume that there is a database and there is some table inside this database called software engineers. And we would like to create 2 lists of engineers. First list would be the list of engineers that we would like offer kind of training, and the condition for that would be like that. And the second would be the list of engineers that we would like to offer a job with the condition like this. So they call contradictory one. And just as a warm-up, let's run that code and see what kind of output we are going to have. So the offer training list now contains 2 Java guys, which looks okay. And the offer job list contains 6 guys, but one seems to be here accidentally. So there's a J2E fan, which apparently appeared on invalid list. And of course, the reason for that is that our condition here is a little bit too naive. So let's fix it a little bit, changing that to contains method. So that shall help at least for this particular use case. So I will add contains in the first and contains negation in the second case, and we'll run the code again and see what's going to happen right now. So we got on the first list, the list seems to be correct right now. So this J2E guy was moved here. However, if we analyze the second list, something goes wrong because we got 6 guys at the beginning. 1 was moved to the top and only 4 left. So someone disappeared. So what's the problem here? To analyze that, I will add a little bit more logging to our context. So this parameter will make our code to print out the SQL statement. So I will run it again and see what kind of SQL statement are going to be generated. And this is the SQL statement for the first query, and here is for the second query. And we, of course, will focus on this where clause. So as we can see, this contains method actually is translated to string pos SQL function. And the problem stems from the fact that, as you probably know, in SQL, the Boolean logic is of 3 states. So apart from true and false, we have also null value. So if that happens, that favorite language is a null, all this statement becomes null. And negation of null in SQL is still null, which is falsy, which means that if favorite language is null, it's neither meeting the first nor the second condition, which may be not really intuitive. So we need to be really careful about it. By the way, if we are executing contains methods against nullable property, if that was executed as a C# code, that should throw an exception. But we have another proof that it never executed as C# code, because this can be null in some cases, and no exception is thrown. Great, but we may wonder why actually it worked in the first example. So let's revert it to the original structure, and add this logging again to see what is the reason for that. So run it again, and now verify what kind of where clauses are generated. So here I have the where clause for the first query, which is trivial and obvious, but for the second query, you can realize that in this particular case, EFCore will try to help us with these null pitfalls, and will generate compound conditions. So it's not only checking if favorite language is not equal to Java, but it also implicitly verifies if maybe it's not null. But it works only in case of explicit equality, not equality operator. So that means we need to be really, really careful when dealing with nullable properties, especially in case of negative conditions. Okay, so that was all about this demonstration. Let's move to our slides again, to the next one, and take a closer look how actually collections are handled. What EFCore has to do with collections, and it actually happens that EFCore supports any and all operations against navigation properties. So we will create a statement like that, or even like that. So the nested subconditions, everything works fine. So that will be translated and will result in this where exists and inner join set of SQL statements. Nonetheless, if we create a statement that looks at the first glance really similar, but instead of navigation property, we will call any method against some custom collection, so some just fixed list, we will get translation error. That won't work. By the way, if we modify that statement a little bit, I mean, we can just extract this town property by select method and later on call any against primitive type. That will work. So why? Actually, because EFCore tries to be pretty smart, and we realize that in this case, first part does not depend on our entity. It only depends on some external values. So it can be expressed like just town IDs collection. And any against any with explicit equality check is nothing more than contains. And because it's able to translate it, this kind of expression into this bottom one, it works, because this kind of statement works as where in SQL clause, as we've seen in the previous slide. But it is really narrow use case, as we add a little bit more logic. For example, checking both town and street, there is no option to use it. And if we go back to our domain of engineers and favorite languages, and we would like to create condition for this kind of logic, so assuming that there are more than one language that we would like to examine, and try to create something like that. So there is a list of desired languages, and we are looking for engineers that meets at least one of them. We will also not be able to translate this kind of statement. What we would need in this kind of case would be the expression of this form. So something that iterates over every element of desired languages collection, calls contains, and combine results using OR operator. And of course, that's not possible using Lambda syntax, but here actually raw expression API comes with help, because that will allow us to assemble this kind of expression in a dynamic way. And this is something that I would like to present right now. So let's move for the last time to our presentation to the codes and to demo number 3. Okay, and let's try to solve that problem. So in this code snippet, first I'm defining the list of these desired languages. Now, for simplicity, it's only 2 elements here. And I will try to create the offer job list, assuming that we can accept both Java and C# developers. And as long as the condition contains explicit equality operator, so desired languages, any of them matches, that shall work. Thanks to this fact that this any means more or less contains. So EFCore should be able to handle that. And yeah, no exception. But if I change it to the contains displays, I shall fall into trouble. No, nothing. And the output will not be produced. And instead of that, I will get translation error. So, legal expression cannot be translated. Okay, so let's try to fix that. We'll start with defining our expression tree, of course, with defining parameter. And in our case, this parameter right now would be entity. So the type of that would be software engineer. And right now, we'll try to iterate over every element of our desired languages array and create subcondition for that. And finally, we'll aggregate them using OR operator. So let's use some functional approach. So I will define the body of our expression, and that will be created in that way. So we are taking all desired languages and using select method, I will try to create sub-expression of that. Compiler is not able to infer expression type, so I need to define it explicitly that I would like to create sub-condition that has this kind of signature, so typical predicate against software engineer entity. And let's call it X, and we can here use leverage from the fact that compiler can translate it, so I will not assemble that manually completely at this point. So let's call it entity. Actually, I will copy paste that because that's supposed to be the same. And in that way, I created the lambda expression that represents our subcondition for particular desired language. However, I'm not able to aggregate, to combine lambdas using logical OR, because lambda contains both this left hand and the right hand side part. So what I can combine using logical OR is the result of lambda invocation, not the lambda itself. So this is why I need to return the lambda invocation, not the pure lambda, and for that there is of course corresponding factor method just invoke, and I will invoke X with our parameter. And right now I can use aggregate method expression.or, so that shall work. Now compiler complains about some type inconsistency. It is because this OR method returns the object of binary expression type, while invoke is an invocation expression. But all of them have the same base class expression. So if I cast to the base class, there is no more complaints. And if we have body, we can convert it to the lambda expression. So wrap it into this. Lambda expression wrapper as in the previous example. So I will declare lambda and on expression dot lambda, I will copy the signature, and here I need to provide again body and our param. And actually we are done. Right now I can take this manually assembled expression and just paste it to this where clause instead of defining it manually, and try to run the code and see if that helped. And for a moment, and yeah, here we are. Right now, our list contains 5 guys. So this J2E guy, is no longer missing, and everything works fine. This class of problem is really common. Actually, and it's also really flexible because in this subcondition that we defined here, we can actually put anything that is supported by EFCore. And this is so common that Microsoft decided to create some utility class that's doing more or less the same thing, not exactly the same, but more or less. That helps us to define the same logic in a more concise way, and eventually without, again, using expression trees API directly. And this utility is called predicate builder. So I'll try to use it and show how it can be done shorter. So let's define this, this entity, predicate builder, and here I need to define type of our entity. By the way, this is a part of Linku NuGet package, so it's not imported by default. But this predicate builder is a really simple class. It's stripped from comments, is more or less 60, 70 lines of code. So you can analyze that and see how how it works pretty easily. And right now, if I define this expression starter, I can iterate over our desired languages collection, and for every item I can do pretty simple things. So I will set predicate is equals to predicate, or, and again copy paste our condition here. And actually that's all. Thanks to implicit constructors of those classes, I can right now copy paste here. And it shall work again in the same way. So just verify if I got the same output. Yeah, 5 guys, the same one. If we now use some automatic refactoring, I'm getting really concise and readable form of that. And this is actually the preferred solution I would suggest everybody to use. Of course, there are some use cases when using this raw method, raw approach is more flexible, and maybe there is a class of problem that cannot be solved using this predicate builder, but it's rather unlikely. But on the other hand, if some random engineer in the future would need to maintain the code you create, it's much more likely that he or she will know how to deal with that rather than with that, as long as not expression trees fine. Great. So that's all for this demonstration, and there is actually one more thing I would like to present. One more use case for expression trees with some non-obvious use case, which may be called universal conditions. What do I mean? Sometimes it happens that we would like to create some set of conditions that we would like to reuse in different scenarios. So, for example, in multiple database queries, and sometimes both in database queries and sometimes in client evaluation. So let's add a little bit more complexity to our job offer logic and create a record called job offer, which will contain 3 fields. So first of all, there will be a company name which is making the job offer, and the language that is requesting for, and finally the number of experience years that is required. And with this kind of approach, it is convenient to attach our set of conditions to this kind of entity. So this is what I'm doing here. I'm defining the DB expression auto property inside our record with this kind of signature, so raw predicate that can be later on injected in database queries. So expression that is of the signature from software engineer to bool. And here's my logic. So I don't want favorite language to be null. I would like my favorite language to contains the one from the offer, and finally experience years of our entity shall be at least as large as the one from the offer. Okay, so let's see how it works in practice. Here I have a couple of lines of code which are creating 2 offers. One for Java and the second for C# for different companies, and defining some experience in years values. And in the next line, I try to retrieve the Java devs that are meeting our Java offer condition. So I'm taking the software engineers table again and executing query where query, but I'm not defining the query here, but referring to this DB expression property, which seems pretty reviewable and fine, and probably will work. So let's double check that. What's going to happen if I get some output? Yeah, and here it is. So 2 Java guys that has at least 4 or 3 years of experience. However, in the meantime, we actually created kind of ticking bomb code. Why? Let's add the most innocent line that anybody can think about it. So just bring out to the console, for example, our Java offer entity and see how it looks like. So I just would like to see how this record is presented. It may happen, as a part of some probably error handling, and instead of our Java offer contents, I got Stack Overflow exception. So this is the problem that can blow up, in the last expected moment, because hardly ever we are actually printing out to the console the contents of our entity, as long as it's not some exception handling method, which may, encounter this pitfall a couple of months after we create that code. What's wrong with that? So the problem is that, the default two-string representation of a job offer of any record includes in the output all properties of the record. So as long as DB expression is a property, it will be included as well. That's great, but in this case, this DB expression refers to the record itself because it's the part of because it's the part of this instance. So it will trigger the job offer to string method as well, creating infinite recursion. And this is why we got Stack Overflow. So that's the lessons learned from that. Never ever define expressions, as properties inside records. To fix that, I can add this parenthesis. So I just created a method, and this problem no longer occurs. So I just need to add this here and here, so we can double check that if that works right now. Okay. Yeah, so far so good. It looks okay. So right now we can get rid of that and move forward. Let's imagine that we got a new requirement from our business, and we are asked to prepare the logic that is able to take as an input the list of Java offers, and will return the report. But for every job offer, is presenting the list of candidates that are matching the condition. So pretty easy stuff. But we may realize that as this list may be long, and most of engineers in our database meets at least one of those, it makes sense to get all of them at once instead of querying database for every element, and evaluate our logic on the client side. So this is what I'm doing here. I'm just taking all depths from our database and try to do the mapping on the client side. So this pretty simple logic. I convert the job offers to dictionary when the key is just company name, and the list of candidates is evaluated like that. So I'm getting all of them, executing where clause, taking our DB expression, so trying to reuse the logic. But here is the client evaluation, so I need a lambda instead of expression, so that I need to compile it, getting to list, and see if that's okay. Pretty fine. That output is as expected. However, now in real world, our list may be a little bit longer. So let's see what's going to happen if I duplicate our list. I have some helper method for that. So that will result in trying to execute the same code, for 4,000 entities. And if we right now wait for our results, everything looks fine. However, the one concerning things is the runtime. So it's more than 3 seconds. It's a yellow flag. And in the real world, that would be probably even worse, because the compile method execution time depends on the complexity of the expression that is compiling. And here we got the trivial one. So probably, even order of magnitude smaller number would, cause a severe performance problem. So how to help out? How to make this compile method not to be executed for every job offer instance? Because that's actually the problem for that. We are executing heavy methods, 4,000 times. With this kind of signature, it is not actually possible because our DB expression refers to the instance field, which means that is more or less different expression for every instance. So what we'd like to achieve is to create maybe static version of that expression that will take the instance as a second argument. So that if that would be static, maybe we can compile it only once, and that shall help. So let's try it out. I will call it static expression, and static is no longer need this. It can be defined just as a field. But right now I need to change the signature. So it's not only function of entity, but also job entity and job offer. And here I can refer to our fields. Great. So we have a static expression as a static field. Maybe I can create a compiled version also in the static way. So if it's going to be compiled, it's no longer an expression. I can call it compiled expression, and I will say that it's the static expression dot compile, and it will be done only once. Okay, if I have a static version of compiled expression of this signature, I can create the instance version of that lambda that will just leverage from that. So right now I'm trying to just copying the signature, and will define something which I will call lambda, and that will work like that. So I can, that would be a function of entity only, and we'll execute our compiled expression using providing the entity parameter, and the second parameter would be this. So this is the instance version of this static expression. And right now I have extracted this lambda delegate with the signature as that, so we can try to use it in our conditions. So no longer referring to DB expression, but to this lambda. I no longer need to compile it, and I can run the code and see if that helped at least a little for our performance problem. So let's check it out. What would be the execution time? And it's much better. That was 3 seconds, and right now it is half of that. Fine, but there is one problem with that approach. To maintain that, I actually needed to copy our conditions, which is something I wanted to avoid, and I can't just get rid of that because it's the only thing I can use in a database. So what we can do is to maybe try to do the same trick as we did with lambda here. So just refer to the static expression and create the instance version of that does not copy the logic. So let's try it. I will create this method, get rid of that, and what we need to do is to modify somehow our static expression. But if we are talking about modifying expressions, the only utility that is valid for that is something which is called expression visitors. This is a utility provided by Expression API. And the way how they are used is that by creating derived classes for that are doing something. So let's create this kind of class. So define my visitor that will extend the expression visitor. And the intuition says that as we are going to replace one of parameters with some fixed value, we need to declare it. So to have instance access to that. So I will declare job offer, we call it fixed param, and provide private getter and generate constructor for that. Okay, and the way how expression visitors are supposed to work is that they actually iterate, traverse rather, over every node of our expression tree, and it gives us a chance to modify those nodes. So what to do if we want to modify something? We need to provide some overrides. And if I take a look at the overrides proposals from that expression visitor, there's a bunch of different methods that I can override. One for every type of expression node. And in our case, what we are going to modify is a parameter. Because our task is to replace one of parameters of our expression into the constant, so it's no longer a parameter. So I provide override for visit parameter method. And this method is supposed to be called twice. Once for our entity parameter, and the second for job offer parameter. So to learn which actual invocation is that, I can check just the type of our node that is invoked. So type equals type of job offer. And if so, I would rather return the expression .constant. So I'm just replacing this job offer parameter with our fixed param. And if it is not job offer, just do nothing, so return node. And that's actually everything we need to do to have visitor working like expected, so we can try to use it. So let's try to define how the body of our modified expression should look like. So we will use our myVisitor created with this. So right now we can inject this fixed param here and call visit method against our static expression .body. And that's all as for body. Right now we can try to return the lambda expression. So again, I need to use this lambda wrapper. So return expression .lambda with signature. Right now, signature of only software engineer to bool, so without this job offer as a parameter. And the body is already defined. What about parameters? Actually, here I'm going to take the invocation parameter from our original expression, parameters, but only the first one, because the second was just replaced by our visitor. And that's more or less everything. Let's verify if right now our code still works, because we did the refactoring that just removed that logic duplication. And right now our code reuses that. And still everything works fine. So we are able to use our set of conditions defined in that form, both as a part of DB expression and as a lambda, having that compiled only once, so it is lightweight and can be reused in multiple places. Okay, that was the last demonstration I wanted to show. My intention was to show a couple of non-obvious use cases for using expression trees API in EFCore development. And as we're actually running out of time, my summary would be really brief. So go back to our slides again, to the thank you slide. And to be fair, actually at the end it would be convenient to mention at least, yeah, sure, to mention that expression trees, is really pretty strange feature. Because from the one side, it's really powerful. From the other, it's used mostly in some internal libraries rather than in application code. However, there's still a couple of use cases when knowing the internals of that may help us to solve some problems much more efficiently. Great. That's all from my side. I wanted to say, if you have any questions, don't hesitate to ask it. But as for now, I'm leaving the stage. Thanks.